convex lens and the concave lens. Convex lens is similar to concave mirror. Okay, and concave lens is similar. It is similar. Okay, concave lens is similar to convex mirror. Okay, why? Because these two are diverging and these two are the converging. That is the result. This is convex lens and the concave lens. Then what else we studied last class? Convex lens. In the convex lens, we have the optic center F and the 2F. 2F is the center of the curvature. Here also you have F and 2F. Okay. So, one ray parallel to the principal axis, how it goes? Any ray parallel to the principal axis? It passes through the focus. Then
ఒకసారి చూసుకోవచ్చు ఇలా అయితే కట్ చేసి ఒకసారి కట్
అవునండి చేస్తాను. Okay, then another ray, if it is passing through the optic center, it goes without deviation. We studied that. And the third one is any ray which is in the direction of the focus will be parallel to the principal axis. All the three we studied. Now we will try to study about the images. Now we will try to study about the images formed by the lenses. Okay. So first we will see the convex lens where the if you keep the object at infinity. Okay, if you keep the object at infinity, where the image will be formed. Image formation. Image formation. Okay. By a convex lens. Write the diagrams neatly. Okay. So first one, this is the optic center and we have F and this is the 2F, F and 2. Okay. Now, if you keep the object at infinity, when the object is at infinity, then most of the rays will be parallel to the principal axis. Most of the rays will be parallel to the principal axis. So, all the rays which are parallel to the principal axis will pass through the focus. It will pass through the focus. Okay, it will pass through the focus. So, object at infinity. Object is at infinity. Okay, image is formed. Image is formed at F. If you want, for simplicity, keep it as F1, F2. Okay, here the focal length will be same. All the four that what we observe, like optic center to F on both the sides, then F2 to F, all distances will be equal. Okay, so image is formed at F2 here. Image is formed at F2. So what type of the image will be formed here? Real and inverted. Whenever you get real image, we get inverted image. Okay, real and inverted image, and it is a highly diminished image. Highly diminished image. Diminished image. Okay, highly diminished image is formed. So object is at infinity, image is formed at F2, real and inverted image is formed, highly diminished image is formed. Then optic center F1 to F1, F2 to F2. Okay. Now we are keeping the object beyond 2F1. We are keeping the object beyond 2F1. Now first one was at infinity, very very far distance. Now it is beyond 2F1 at some finite distance actually there. Okay. So beyond 2F1, huh. Okay. So one ray parallel to the principal axis passes through the focus. One ray parallel to the principal axis passes through the focus. Then take the other one which is passing through the optic center. Then consider another ray which is passing through the optic center. Okay. So from this point the two rays will meet here, correct? So this is the image form. This point the rays will meet at this point. So that means image is formed like this. And if we observe here, we get the image between F2 and 2F, F2 and 2F2, and it is a real and inverted image, and it is a diminished image. Okay, that means if candle is 10 centimeter, image will be maybe 5 or 6 centimeter like that. So object beyond 2F1, image is formed between F2 and 2F2, and here we will get real and inverted image. It's a diminished image. Okay, it's a diminished image. It's a diminished image. Diminished image means it is a reduced. When you compare to the object, it is less. The size is reduced. So object kept at 2F1, image is formed at 2F2. Size of the image is equal to size of the object, is equal to size of the object, and we will get a real and inverted image. Okay, we will get real and inverted image. So in the concave mirror, where we used to get size same, if we keep the object, where we used to get the same size, right? In which case we used to get that? In the concave mirror. In which case we used to get this image size and the object size same? Correct. C. Here also it's 2F1. It's the same as C. Understood? So concave mirror, convex lens, they are very similar. Okay. So fourth one, next case will be between 2F1 and F. Okay, 2F1 and F1. So one ray parallel to the principal axis passes through the focus. Okay, so another ray passing through the optic center, it should go without deviation. My F1 and F2 is little bit like reduce, increase the length. Object between two F1 and F. Image is formed. Image is formed beyond 2F2. Image is formed beyond 2F2 and it is a real and inverted image. Okay, inverted image. It is an enlarged image. Enlarged image. Okay, and here if you observe, in the lenses on the other side we are getting real and inverted image. If you observe here, on the other side of the lens, okay, we will get real and inverted image. Then fifth one, now object at F1. Object at F1. Okay, so now we will get the image at the infinity. We will get the image at the infinity. If you keep the object at infinity, we will get the image at F. When you keep the object at F, we will get the image at the infinity. So one ray parallel to the principal axis passes through the focus. Okay. So now another ray passing through the optic center. Passing through the optic center. See, it is meeting at infinity means somewhere at some long distance it will meet. Okay. Here, if is telling that it is meeting at infinity, that means somewhere at a long distance they will meet. Okay. Here actually distance keeps on reducing. At some point of, you will get an image. That is the meaning. Okay. So object at F1, image is formed at infinity. Image is formed at infinity and we will get a real inverted image. Real and inverted image and it is highly enlarged image. Highly enlarged image. So if the object is between F1 and the optic center. It is between F1 and the optic center. So one ray parallel to the principal axis passes through the focus. Another ray passing through the optic center. Passing through the optic center. Actually, this side, what happens? The width keeps on increasing here, this side. Okay, so here, actually on the other side of the lens, the image is not formed at all. On the other side of the lens, the image is not formed. Okay, because when the image is formed, when the rays meet, then image is formed. Here actually, on the other side, the rays will not meet. Okay, so if you extend this, if you extend this, somewhere they will meet. So here image is formed on the same side. Image is formed on the same side of the lens where the object is kept. Okay. Image is formed on the same side of the object. You can write like that. On the same side of the object. And here we keep the object between F1 and optic center. The last case we get virtual and erect image. So in the lenses, when you get the image on the same side, we will get virtual and erect image. What doubt you have? Huh? I didn't understand what you said. Okay. Virtual and erect image, and it is magnified image. Okay. So one ray parallel to the principal axis, we know that any ray parallel to the principal axis will pass through the focus. And another ray which is passing through the optic center will go without deviation. So we have considered the two types of rays. And here we observe that on the other side of the lens, the rays will not meet. Okay, so if you extend them, we feel that it is meeting at this point. So image is formed here. It's a virtual image. And whenever it's virtual, it is erect and we will get a magnified image. And one that main key thing you people remember, write a note. In the lens, real image is formed, real image is formed on the other side of the lens, on the other side of lens. Always like that, okay? And virtual image is formed, virtual image is formed, okay, virtual image is formed on the same side of the object, on the same side of the object. In mirror, it was opposite. Do you remember? In the mirror, it was opposite way. When you get behind the mirror, it is virtual. In front of the mirror, it was real. By a concave lens. By a concave lens. Okay. So in the do you remember in the convex mirror? How many cases we have? Convex mirror? Convex mirror. Two cases we had. Similarly, concave lens also we have only two cases. Okay. So any object at infinity, any object is at infinity. So any object at infinity, then rays will be parallel to the principal axis. See, whenever the object is very far, most of the rays will be parallel to the principal axis. Okay, so that is why the rays which are parallel to the principal axis passes through the focus. Sorry, here diverge from the focus. Actually, it diverges from the focus because it's a diverging lens. No, it diverges from the focus point. Diverges from the focus. Okay. So actually here on the other side image is not formed because the rays will diverge, but it diverges from the focus point. It appears to diverge from the focus point. That is why image is formed here on the focus. Image is formed on the focus. Okay. So object at infinity. Object is at infinity. Image is formed. Image is formed at focus. It's a virtual, erect, and highly diminished image. Highly diminished image. Second one. Second case where the object is kept at some finite point. Object is kept at some finite point. Okay. So where the image is formed, one ray parallel to the principal axis, so appear to diverge from the focus. Now another ray passing through the optic center. Another ray passing through the optic center. It goes without deviation. So rays here it is formed. Now the other third case also you can consider here. That is like any ray in the direction of the focus. In the direction of the focus will be parallel to the principal axis. That also you can write like this. Any ray in the direction of the focus, if you want. It will be parallel to the principal axis. There also object is at some finite distance. Okay. It passes without deviation. It will not retrace back. Concave lens, that also. when it is passing through optic center, it goes as if it is going straight without any deviation. Can I take 100 carbon to principal axis and otherwise positive? You can take. Image is formed. No? Understood? No. Image is formed between F1 and O. And here you get virtual, erect and diminished image. Virtual, erect and diminished image. Diminished image. Okay. So until now we studied, like in the mirror we studied 6 plus 2 8. Here lenses 6 plus 2 8. Total 16 ray diagrams we have drawn, right? So these are the one which comes for the exam. Minimum one ray diagram it will come in the exam. Compulsory it will come in the exam. Okay. So from light chapter it is around like many times around 7 to 8, sometimes more than that also it will come marks. And between that, 1 5 mark question comes from the light chapter. Okay. So mainly the ray diagrams will not change. Only what you have studied within this only will come. But you should be able to identify which case I have to write and which type he has told, whether lens, mirror, depending on the clues what he has given, you should be able to identify. It's about the formulas. Write down this lens formula. Lens formula. We have 1 by V minus 1 by U is equal to 1 by F. Write down this. V is the image distance and U is the object distance. F is the focal length. F is the focal length. Okay. This is the first formula. Next you have magnification. M is equal to V by U. Here it is M plus V by U. There it was minus V by U when we were doing in the mirror. Okay. M is equal to plus V by U. What is M? M is a magnification. Magnification. Okay. Now M is equal to plus V by U. Okay. And M is also equal to H naught by object. No, wait. HI. HI by H naught. Where HI is the height of the image. Height of the image. And H naught is the height of the object. It is the height of the object. Okay. So, when you observe these two formulas, what we get? Hi by H naught is equal to V by U. Hi by H naught will be equal to V by U. And another one, what we have, R is equal to 2F. R is equal to 2F. Radius of curvature is equal to 2F. That is also the one what we get. Now, M, think. Okay, these are the formulas what we have to remember. These are the only formulas now. Now, tell me, for example, we have M is equal to, I will write plus 0.4. So, what plus indicates what? Here. M is equal to, I will get value plus 0.4. From that, what and all you will know? Image is enlarged. Okay. Then others, Sahana? Virtual and direct. Okay. Then image is enlarged according to you. What about Sahana? What you will indicate? See, whenever the plus, so here it does not mean like plus means a positive number or a negative number. Okay, so plus sign plus or minus, it just indicates whether it's a real inverted or the virtual and erect. Plus will indicate it's a virtual and erect image. Okay, so here plus will indicate it's a virtual and erect image. Okay, value, it is less than 1.4. So it is a diminished image. So you have to take value separately and the sign separately. If it is plus, it is virtual and erect. Okay. And whenever it is a 0.4, that is less than 1, then what does it indicate? It indicates it is a diminished image. Okay. So you can write note. Wait. Positive sign, write as a note. Positive sign indicates virtual and erect. Okay. If you want, write an example like this. Negative sign in M indicates real and inverted image. Example, write M is equal to minus 0.4. Here minus indicates it should be real, like that. Or minus 2 only you write, because enlarged you will get right small. Okay, write down M is equal to minus 0.4. So write down M value greater than 1. If M value is greater than 1, it indicates enlarged image. It indicates enlarged image. Okay. Then M less than 1, value of that, if it is less than 1, it is a diminished image. Right example here, greater than 1. No? Minus 2 only will write it. And when M is equal to 1, it is size of image is equal to size of the object. When M value you get equal to 1, size of image will be equal to size of the object. Okay, and another thing, now F is the focal length, right? F is the focal length. Now for a concave lens, for the, write down this, for the concave lens, focal length is negative. Always it is negative. Okay, wherever concave comes, no, there it is negative. Both lens and mirror it comes like that. Okay, for the convex lens, focal length is positive. That is, we consider it as a positive. Okay. And U is always negative. U is what? Object distance, right? And you will keep it in front of the lens. So U will be always negative. In lens also it is like that. U is always negative value. You have to consider. Okay? Because in the problem they will not specify like the sign. For everything just give the number. So you should know according to the convention, sign convention, you have to take that. Okay. U is always negative. V depends on where image is formed. If it is formed on the other side, that means what? V will be positive. If it is on the same side, U is there, then it will be negative. So where image is formed, according to that, you have to consider. Okay. Then the last topic, power of a lens. Power of a lens. So, power of the lens. In your book, it's not there. It's there. So, power of lens means it is the ability of the lens to either converge or the diverge. It is the ability of the lens to either converge or the diverge. See, spectacles, usually one will have the power of 2, other will have the power of 4, like that, right? So what is that power indicates how much it is the lens is trying to converge or diverge, depending on what type of lens. Okay, so your eyes is having more power means they will give the power of the lens will be more. That means what? So you need more converging or more diverging lens, like that. Okay, and that is inversely proportional to the focal length. That is inversely proportional to the focal length. Okay, write down that. Power of the lens. Power of a lens. The ability, so the ability of a lens to converge or diverge. How much it can converge or how much it can diverge. Depend that ability we call it as the power. The ability of a lens to converge or diverge light rays is called power of the lens. Power of the lens. What is the SI unit of power in this? Here, in the lenses I am asking. So power of a lens we are studying. What is its SI unit? Pavan, Netra, what is the SI unit of this power? It is called diopter. Okay, it is called as a diopter. D letter we use. Write down SI unit. SI unit of power is, okay, is diopter. Diopter. Symbol is D. Okay. So when, for example, we consider power is equal to 2D, we will consider 2D. Then we know that power is what? It is inversely proportional to focal length, right? If we keep the power in diopter, focal length will be meters. Okay. And power is equal to 1 by F. Power is 1 by F. If power is in diopter, focal length will be in meters. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.